Okay, so now that we saw with Amy the PageRank algorithm, and also with Amy, we saw all the theory to learn about the eigenvector and eigenvalue, let's see how we compute everything. So here for this exercise, you will just need one library in Python. It's the NumPy library. Here is the importation. And here, do you remember our matrix that Amy showed us? It's our matrix M, it's the same one. So here you wrote this way, and you have your matrix. Perfect. To compute A, we need now to calculate the transpose of our matrix M. Here is two ways to do it. Or you do M dot big T, that's important. Or you say you can do M dot transpose. And this gives you actually the same result. And now we can finally calculate our big matrix A. So A is the inverse of the matrix, of the transpose of the matrix M. And as you can see, since in our matrix you have 0, and you can't divide by 0, you will have infinite. So I had this line to replace all of the infinite by 0. And here is the result. From here we can finally solve our equation with A. It's minus lambda identity times our vector, it's equal to 0. So remember, A is the matrix that we just calculate. Lambda, it's the eigenvalue. And here ID is the identity matrix. And the V, it's our eigenvector. And now we're going to solve it. For this, you just need to do np.linag.egg. And you're done. Let's do that. That's the magic of Python. So you have your eigenvalue and eigenvector. And for example, if I print the eigenvalues, here it is. So what does this function do? This function gives you the index of the biggest eigenvalue. So for example, like it will be 0, 1, 2, 3. So that's the index. So 0 is the index of this eigenvalue, and indeed it's the biggest one, and so on. And now I want to reorder my eigenvalue that I have here in the order from the biggest to the smallest eigenvalue. And this is what I'm doing when I do here, eigenvalue, depending on the index that we just calculated previously. So now that we reorder our eigenvalue depending on the order, from the largest to the smallest, what happened to the eigenvector? We do the same principle. And here is the rearranged eigenvector. Remember, for the PageRank algorithm, you want actually the first eigenvector. And it's what we're going to do. So, because the first eigenvector will give you the highest PageRank that you want to. So, by doing this, you take the first one, and here you normalize your eigenvector. And let's compare if the results are correct. So this line allows you to calculate A times the eigenvectors divided by the eigenvalue. And what you get is actually the same eigenvector. And here you go. Great job, guys.